I think it's useful to point out at the bottom of page 84, moving on to page 85, where he says, let the term of multiplicities which possess the properties of not belonging to themselves, which is not beta being not included.
It's just right as beta does not belong to itself.
Yeah, beta does not belong to itself as ordinary multiplicities, and for the reasons clear made in meditation 17, which have not been read yet. Those which belong to themselves, beta belonging to themselves, are eventual multiplicities. So he makes a distinction between ordinary and eventual multiplicities. Can you say a little bit more about that?
Yeah, I mean, I guess to a certain extent, I'm not sure what you're looking for. He makes it clear the ordinary is what is going on in ontology.
Okay.
The eventual is what happens in the math of the event, which is going to be in the second half of the book.
Okay. Which is the being portion of it.
Right.
So
No, that makes sense. Thanks.
would you say that ordinary multiplicities align themselves with being, and these other eventual multiplicities are events? Or would you say that's too simplistic?
I think that's far too simplistic, and as we get into the actual events, we'll be able to examine it more closely. But there's an entire host of conditions for an event to exist, and in fact, right, this is why a good half of the book is based on it, not the least of which the generic procedure, the operations of fidelity, and of course the ever-looming threat of naming the void rather than naming the event. So again, we'll get into this in the second half of the book more clearly. Again, meditation 17 is the math theme of the event. So what it should be clear is for the eventual set, or for the eventual relation, right, which is B belongs to B, that itself is a math theme. That the fact that it's a math theme does not entail that it would arise in ontology as such, right? Because he explores the math theme, Frege's math theme. Mm-hmm. That doesn't mean it's correct, that doesn't mean it's consistent, right? So this is a math theme that will be explored in depth in the event side of being an event.
So would you say then that we use the math theme in set theory to explore different things in different ways?
Yes.
So particularly this sort of ordinary contradiction is what makes it so set theory can establish ontology.
When you say ordinary contradiction, what exactly?
What I mean is, excuse me, and use proper language, ordinary multiplicities are established for ontology.
Yes. They arise out of the axioms of set theory. We're also going to have another axiom that we'll explore in great detail later, which is the axiom of foundation. And again, it's important to note, right, this is a decision. He makes it clear that to exclude the eventual math theme is a decision that's made on the axiomatic level, which again we'll see more deeply in the axiom of foundation. But also, given that the entire point of formulating set theory, and perhaps now is the time to be much more precise, it's not just set theory. Cantor has a set theory. Frege and Russell have a set theory. This is the Zermelo-Frankel-Cantor set theory, right? So it's a certain set of strategic axiomatic decisions. And one of those, and the reason why it's made, is to maintain the consistency of set theory to the extent that it can be maintained consistently.
Right, and it probably is also worth pointing out that this is what mathematicians do, is they also look at the potential elimination of things like axioms and things like this. Higher mathematics and geometry and things like this take and examine and look at things of Euclid. So this isn't merely just something that a philosopher would do just for the hell of it. This is what mathematicians do. Yeah. So I just thought that was worth pointing out.
So are we good on this section for now? Okay, so let's go to the void and the excess. Again, remember, what he's going to, he asks these questions expecting our common sense to run aground, and quite frequently it does, right? The void is a subset of any set, which seems counterintuitive because the void, right, it exists. And also the void possesses a subset, which is the void itself, which again seems counterintuitive because how could a void possess a subset? But Badiou will go into it. So what he points out is that anything follows from the false or this is 87. And so we have the formula of this, which is not A, their implication, and you can simply infer any implication on there. A therefore B. So he points out that that nothing belongs to the void. So what we have is, not A is it is not the case that A is an element of the void. Therefore, A is an element of the void. Therefore, A is an element of B. So basically,
That's the second tautology on 87.
Yeah. So basically, what we have is you'll notice that second part is just the axiom of the power set. So does everyone notice that? It's just it's essentially a reformulation of the axiom of the power set, right? Except instead of gamma, we call it A, right? So here's the thing. It's true, right, that it is not the case that A is an element of 0, right? Because how could anything belong to the void? So because that's true, therefore, right, if A is an element of 0, therefore A is an element of B, which is to say that for any given multiple of 0, right, which in this case would be none, there can also be a multiple that is of another set. And what is this? This would be the power set. So, of course, this leads us to its reduction, which makes things a lot simpler to write out, which is why I'm only going to write this. For all B, yep. And again, it should be quite easy looking at the text how that's just a reduction, right? I'm not gonna put it up, or I guess I kind of have it up here. Basically, you have this. Except it's A is element of void, A is element of beta. This condenses down to just inclusion, right? Gamma is an element of A, which again condenses down to, or not element, included. Void is included in beta, right? So does everyone understand how that reduction works, how that argument works? So this is what entails that for any given set, the void is included. And then of course, right, he goes on to say that every set includes itself definitionally. So A is included in A. The set of subsets must also apply to the set of the void. So what's included in 0? There's a really commonsensical, easy way to think of this. What are the things in 0? Void. So what is included in 0? Void, right? There's no, to a certain extent, there's no overlap. Of course, right, again, it's definitionally true.
So you just really coarse way of saying void equals void?
Yeah.
Okay.
Well, void includes void,
okay.
right? Because if you, through a formula, I mean, we don't necessarily have to do this, but if you take a formula of female presidents, what's included?
None.
Right, a void,
Right.
the empty set. And then if you take any formula of that set, or the power set of that set, you're also going to get a void.
Yeah, no, that makes sense.
Okay.
So what's included in nothing? Nothing's included in nothing, therefore.
The void.
Right. Well, to be precise.
Yeah. But it's important that the inclusion of the void is understood rigorously. And the reason why is because we're going to soon see you can continually take power sets of the power sets of the void, right, and arrive at infinite complex multiplicities. So let's move on. So that was, I have page, oh, that's power set of the void. That was about page 87. So then we also have the power set of the void is a unique set, which the void belongs to and is included. Furthermore, the entire series of sets can be generated out of increasing power sets of the void. This is 88 to 89. As we stated earlier, when we were talking about the power set by the axiom of extension is a different set from the set of A, right? Power set of A is different from the set of A. This entails that the power set of the void is different from the void itself. So let's see. Let's look at this then.
This all roundabout has something to do with the idea of being able to give a formal name to the void. Is that correct?
Could you say more? I don't believe that's correct. Let me just say what Badiou's project is, and then you can tell me if that corresponds to what you're saying. What Badiou is trying to show is that you can generate an infinite multiplicity at this point. What Badiou is trying to show is you can generate an infinite multiplicity of complex sets out of nothing but inferential axioms, i.e. the power set, and one existential axiom, which is the void.